Hello everyone, myself Dr. Sadhana Santosh Raut, Assistant Professor, Senior College of Pharmacy, Vadgaon, Pune, going to discuss antimicrobial agent from pharmaceutical inorganic chemistry subject. Let's start with the different terms which are related with antimicrobials. There are four different terms such as first one is antiseptics. So, the antiseptics are substances which are able to kill or prevent the growth of microorganisms, but particularly that can be applied to living tissues. Second, germicide. These are the agents which kill the microorganism, that is bactericide, fungicide, amebicide, viricide, etc. Third one term is disinfectant. This term refers to the same type of activity as germicide. It refers only that it should be applied in inanimate object, that is non-living things. Last one term sterilization, that is referring to any process that kills all forms of life including fungi, bacteria, viruses, spore forms, etc., which are present on a surface contained in a fluid, in a medication, or in a compound such as biological culture media. Sterilization can be achieved by applying heat, chemical process, irradiation process, high pressure and filtration or combinations thereof. Secondly, we have to see ideal properties of antimicrobial agents. Antimicrobial agents should possess antiseptic and germicidal activity, not static activity. It should have rapid onset of action and sustained activity. It can possess good therapeutic index. That means it gives the maximum biological activity. It should not cause local cellular damage, not interfere with the body defenses. No systemic toxicity. Have broad spectrum of activity and also have good lipid water distribution. Secondly, mechanism of action of antimicrobial. So, antimicrobial activity can act through three ways such as oxidation, halogenation, protein binding or amongst this, first one is oxidation. These compounds belongs to some kind of compounds such as peroxide, peroxyacids, non-metal anions, oxygen liberating like permanganate, hydrogen peroxide, metal peroxide, halogens such as chlorine, iodine, oxohalogens, etc. These causes oxidation of active functional group which is present in the protein or enzyme which plays a vital role in the growth of microorganism. So this causes change in the conformation of the protein and alters its function. For example, protein before oxidation showing presence of free sulfhydryl group, protein after oxidation showing the formation of disulfide bridge between the two SH groups. Second, halogenation. This reaction occurs with antiseptics of hypohalite type like hypochlorite, that is OCl-. These compounds cause chlorination of primary and secondary amides. Amides is nothing but a functional group C double bond O and H. These acts on the peptide linkage directly and alters its potential property. Third is protein precipitation. It involves the interaction of protein with metallic ions having a large charge or the strong electrostatic fields. This property is available in the transition metal cations such as copper, silver, zinc, aluminium, etc. Most metal cations, with exception of alkaline earth metals such as magnesium, calcium, barium, will give protein precipitation activity. Metal ions binds to polar group of protein which acts as a ligand and the metal acts as a Lewis acid. These complex form as a chelate and giving rise to inactivation of protein. But this action is non-specific. These metals agent are not able to distinguish the microbe and that of host. Concentration of medication should be adjusted in this case. The example in case of it is hydrogen peroxide. The chemical formula of hydrogen peroxide is H2O2 with the molecular weight 34. It is having not less than 6% weight by weight H2O2. How it can be prepared? So it can be obtained by adding a thick paste of barium peroxide in ice cold water to a calculated quantity of ice cold dilute H2SO4. That means BaO2 plus H2SO4, it gives barium sulfate, that is BaSO4 plus H2O2 is nothing but hydrogen peroxide. Properties of hydrogen peroxides are colorless liquid, slightly acidic test. This solution decomposed in contact with oxidizable matter reducing agent on standing. The solution is stabilized by addition of small quantities of acid and adjusted the pH in between 2 to 3. Action and uses of hydrogen peroxides are: it can be used as a strong oxidizing agent and yield nascent oxygen, hence it is used for its antiseptic action. Also, it can be act as a oxidizing agent for the bacteria. This is called as cleaning antiseptic. Diluted solution in the proportion of 1:1 is used for gargle, mouthwash or for the treatment of throat infection. It can be also used in vaginal douches and ear wash. Also, it is an effective antidote for the phosphorus and the cyanide poisoning. It is used in bleaching the hair, deodorant, removing surgical dressings. And lastly, the assay of hydrogen peroxide. Assay of hydrogen peroxide is carried out by permanganate method. That means there is making a use of ChemNO4 in the burette and itself it acts as an indicator. In conical flask, we have to take 10 ml of sample, dilute it to 250 ml of purified water and to this add 25 ml of this solution, add 10 ml of fine normal H2SO4. The contents are titrated against 0.1 normal ChemNO4 which is act as an indicator.